Hello and welcome to the second video of the notes for 7.2.2. If you didn't watch the first part of the video where we did problem 7-125, go ahead and watch that video now. It'll be linked in the description below. If you have already watched that video, go ahead and start here reading problem 7-126. Go ahead and read problem 7-126 now. Now that you've read the problem, let's talk about what it's asking us to do. So it wants us to take this information. So the radar line is like a radius of a circle, and it goes around the screen over and over. So she noticed that it takes 2 seconds for the line to travel through an angle of pi over 6 radians. She wants to make a graph where the input is time and the output is the distance from the outward end of the radar line to the horizontal axis. So let's write it this way. Input is time. Output is the distance to the horizontal axis. Go ahead and pause the video to think about what this means. Pause the video to think about what this means now. Now that you've thought about what this means, let's talk about it. So if you look at this circle to the right of the screen, we're looking for the distance to the horizontal axis. So let's say we have a point right here. The distance to the horizontal axis would be this line right here. So if it was over here, the distance would be right here. Over here, distance would be right here, and so on. So now that we've established what that means, let's think about what we could do to graph this. What can we do to graph this function? Now that you've thought about it, let's go ahead and look at the part that says your task. So following the input and output specifications above, let's make a table and then graph Brianna's radar. So first, let's make a table. So we know that time is our input, and let's just say distance for just to save space is our output. So think about how you could fill in this table with inputs and outputs for Brianna's radar. What are the possible times we can use? And for those times, what's the distance to the horizontal axis, or how can we find it? Now that you've thought about how to fill in this table, let's talk about values we could use for time. So we can't have negative time, so the lowest value we could have is 0. We're counting how it moves every 2 seconds. So let's go ahead and count by 2. So 0, 2, 4, 6, 8, 10. So let's start with these points. But if we know the time, how could we find the distance? We know that it moves pi over 6 radians, so how could you find this distance to the horizontal axis? Go ahead and think about how you could find this and look back in your notes, looking at the Ferris wheel problem for how you would be able to find the height when you're thinking about an angle. Now that we've thought about how to fill in our table a little bit, let's look at it in terms of the circle. So time 0 will be over here. At time 2 seconds, we'll be right here. Time 4 seconds, 6, 8, 10, 12. And what these represent are 0 radians. As it goes up 2 seconds, it goes up to pi over 6 radians. Then 2 pi over 6 radians. 3 pi over 6 radians, and so on. How can we find this distance right here for those angles? Go ahead and think back to what we've done in previous classes using that Ferris wheel problem. So how we can find these heights right here. Now that you've taken a moment to think, let's talk about how we can find this distance. So when we were talking about the Ferris wheel problem, we had used sine to find heights, or this vertical distance here. So at pi over 6, we found that it was sine of pi over 6. At 2 pi over 6, we found that it would be sine of 2 pi over 6 for our Ferris wheel. Do you think the same thing will work here? Think about it for a moment and then come back to the video. Now that you thought about it, let's talk about it. We can use the same type of idea where the height has to do with sine of the angle. So the angle at 2 seconds is pi over 6, so we're doing sine of pi over 6. Sine of 0 is 0, so we're going to leave it with that. So 4 seconds would be sine of 2 pi over 6, which is the same thing as sine of pi over 3. 6 would be sine of 3 pi over 6, which is the same as pi over 2, and so on. So we can continue with the same pattern. Sine of 4 pi over 6, so 2 pi over 3. Sine of 5 pi over 6. And lastly, let's extend our table a little bit. At 12 seconds, we have sine of 6 pi over 6, or just pi. So go ahead and look at this table for a moment and think about which would be x and which would be y. So now that you've thought about it, let's talk about it. X would be our time, because that's our input, and y would be our distance, since that's our output. So let's go ahead and move this table over to Desmos so that we can look at how it would look like on a graph before we graph on our papers. Go ahead and pause the video and open up Desmos. Once you open up Desmos, go ahead and hit that plus and then use the table function and just copy over that table. So x was 0, then 2, I can't type, 4, 6, 8, 10, 12. Y was 0, or sine of 0. Sine of pi over 6. sine of 2 pi over 6, and so on. Go ahead and finish typing in the table on your own. Pause the video to do that and then come back. So once you finish your putting in that table that we started, we can see the beginning of our graph up to 12 seconds. So we see from 0 to 12, it makes a little curve going up and then down. Let's go ahead and draw this graph on your paper. Start to draw this graph on your paper, but leave room to graph the second half of the circle on your paper as well. Leave room to finish off the second half of your circle on your paper as well. Now that you've graphed this part of the table on your paper, let's talk about how many seconds you think it would take to go around the entire circle. So we know it took 12 seconds to go around the first half. Pause the video and think to yourself how long it would take to go around the rest of the circle. Pause the video now. So now that you've thought about how many seconds it takes to go around the whole circle, let's go ahead and write this down together. So we have 12 seconds here, then pi over 6 angle radians later will be 14, pi over 6 later would be 16, 18, 20, 22, and to get back to where we started would be 24 seconds. So it takes 24 seconds to go around the whole circle. Go ahead and finish your table in here up to 24 seconds and do the same on Desmos. So remember, each time we go up 2 seconds on our time, our angle goes up by pi over 6, and we're just taking sine of our angle each time. Go ahead and pause the video to finish your table now. Now that you've completed your table on your own, let's go ahead and look at it on Desmos. So make sure that you have your table and put it on Desmos as well as on your paper, all the way up to 24 seconds. So for 14, it goes up to 7 pi over 6, 16, 8 pi over 6, and so on, each time going up by pi over 6. If you click this little dot next to that little Y, you'll see our points show up. Go ahead and finish this graph and think about what type of graph this looks like. So go ahead and finish your graph now using what you found on Desmos. Pause the video now to finish your graph. Now that you've finished drawing your graph, look at these two questions. What graph does this remind you of? So what graph that we've looked at before in this class does it remind you of? And how is it different from similar graphs we've made? So that graph it reminds you of, how is it a little bit different? So looking at this graph right here, what does it remind you of? And how is it different? What does this graph remind you of? And how is it different from similar graphs we've made? Go ahead and answer these questions on your own and take a photo of your notes to submit on Google Classroom. Once again, if you have any questions, be sure to log into Google Meets or whatever your teacher uses for tutoring. I know my class is Monday through Friday, 11 a.m. to 12 p.m. for Miss Red's class. But if your class is different, be sure to log in and ask your teacher questions if you have any. Thank you and have a great day.